Welcome to today's Meet the Service Virtualization Expert session. I am Pamela Deason, head of the DevOps product marketing here at Broadcom. For those of you who may not be familiar with service virtualization, it allows users to create virtual services that actually emulate real systems. With me today is Andrew Gates, a service virtualization product expert. Andrew, can you introduce yourself and let us know what you will be sharing with us today?
Thank you, Pam. My name is Andrew Gates. I am a global solutions engineer specializing in service virtualization. I've worked with the product for 13 years. Today, we'll be talking about how to use service virtualization and the provided service virtualization certificates to key stores to encrypt your traffic when communicating with your real systems. We'll also talk about using your own certificate to authenticate transactions moving back and forth within your enterprise. And we'll also look at enabling SSL between the service virtualization components to support internal security standards and communicating with the cloud. Now, service virtualization needs to analyze clear text coming through it in order to build a virtual service model. These are generally XML messages, database messages, JSON messages, and the like. Now, a system under test that needs to communicate with the backend server could potentially require that all traffic be encrypted back and forth. If it's encrypted, then usually it's using some type of SSL certificate. Service virtualization actually ships with its own SSL certificate. This generic certificate is available to you from the home directory of service virtualization, and it's self-signed and fully trusted. It can be used to accept transactions coming from a system under test that are in clear text, analyze them, generate a virtual service model, then encrypt them and pass them downstream to your backend systems. When the system communicates back with the encrypted transaction, it can decrypt that transaction and pass that back to the system under test. However, if you're looking to use a certificate for authentication, that certificate usually has to be specific to the client that is communicating to the backend server. In this case, we'll need to be able to use that client to server certificate in order to accept traffic from the system under test, encrypt the traffic, and then pass that to the backend server looking like we are the system under test in order to complete a successful round trip. Communication between a client and a backend server using a certificate as authentication will often require that that certificate be specific to the client that's doing the communicating. When you're trying to record transactions to the service virtualization engine and then to the backend server, that can break that type of round trip. What we do is we enable service virtualization to accept the client certificate, encrypt the traffic, and then pass that back to the backend system looking like the original system under test. If we have two-way authentication, if the client has a certificate and the server has a certificate, and we need to enable service virtualization to intercept traffic flowing between them both, we have the ability to be able to accept both a server certificate and client certificate within the virtual service model recording, and then be able to encrypt and decrypt traffic moving up and down our process flow. Now let's take a look at enabling SSL for our virtual service using our workstation. And we'll come in and create a new virtual service image by recording. We'll go ahead and select a transport protocol of HTTP. We'll use a default model name. And now we'll have access to the properties for SSL. Now here, by default, we'll be pointed to our self-signed certificate provided in the Service Virtualization home directory. If you want to use your own certificate, this is where you'll do the settings. So as an example, we'll go ahead and select a new certificate key store. I'll go ahead and use my rec keys, which is this provided self-signed certificate that we ship. Now, we'll also need to use the password, and the default password for the self-signed certificate within Service Virtualization is passphrase. We'll click on the blue gear icon, select the password editor, put in passphrase, and then we can verify our certificate. And here you can see that the certificate is valid and usable via virtual service. Now, if we want to use client-server authentication, we can enable client certificate authentication and adds either request or require, depending on our needs. Now, if we're going to be using our own certificate key store, There's two ways we can do this. We can either use a self-signed certificate, or one can be provided by your system administrator. Once you have the certificate, put the certificate in your service virtualization directory, and we'll update the local properties to point to the new certificate key store. If you're using a self-signed certificate and we need to add that to our keychain, you can use KeyTool provided with JVM. And here you can see some of the samples for it to export and import the certificate, depending if you need it for your server key store or your client key store. One thing to note, we do recommend JKS over P12 format for interoperability reasons. Now, when using SSL between components of service virtualization, such as the Identity Access Manager, Enterprise Dashboard, Portal, and all the other components, there are several steps that need to be followed. For Identity Access Manager, by default, they will also be using the self-signed certificate. To use your own certificate, you will have to go into the IAM properties in the home directory for the Identity Access Manager and uncomment the following values. Now, one thing to note, you will find an iam.keystore.pass and iam.truststore.pass. These values are unencrypted, so we do recommend that you use the keystore.password and truststore.password instead. When you configure IAM to access LDAP, especially if you're enabling single sign-on, you must add the public key from the LDAP server into the trust store. And again, you'll use KeyTool following this syntax to import into IAM. For Enterprise Dashboard and Portal, we'll be going to two different property files. For the Enterprise Dashboard, we'll be going to greatest.properties and uncommenting the following lines. We'll also need to go to the site.properties and inform Service Virtualization that Enterprise Dashboard will be accessed via SSL by enabling this property to true. Within the portal, we'll be modifying the Phoenix.properties. For SSL passwords and key stores, we'll use the first four sets of properties for Phoenix.ssl. And for our Jasper reports, we'll need to enable the registry hosts, Res Hub, and registry HTTPS enabled properties in order to properly access resources. Within the various other components, we can modify the local.properties and set the key store file and password, and as well as setting the default protocol to SSL. If we'll be using API calls, we'll need to enable the web server SSL properties, as well as the lisa.portal URL.prefix. To enable communication from your workstation to for example, a registry that is using SSL, you need to go to the local.properties on the location where the workstation will be running and modify these properties, such as Lisa default key store and password, as well as pointing to a portal URL prefix. You can use lisa.net.truststore for your value. Our support staff has compiled a list of commonly encountered technical issues with SSL. Many customers use certificate paths within the project configurations for their virtual services. On deployment, you need to make sure that these certificate paths are using relative paths and not hard-coded local paths. Oftentimes, with self-signed or self-created certificates, they may not have intermediate or root certificates. These are not considered validly formed by service virtualization, so be sure that you have a root certificate before importing. Oftentimes, we act as a man in the middle between a client and a server, so our key store password and private key passwords are used by service virtualization to initiate that communication. Because of limitations of mediating between both, the password must be the same for the key store password and the private key. When creating a certificate, oftentimes the alias will be left blank or a non-real name will be put in, such as a number, 1 or 2. Be sure to use a real name when creating an alias for your certificates. SAN name issues are common, especially when developing locally, and then that particular SAN definition may have moved on deployment. For example, a particular alternative name may point to an IP that no longer exists or was only an internal development IP. Be sure that your IP addresses are the same.
Thank you, Andrew, for all of that great information. You've been very informative, and I hope you'll join us again for other service virtualization topics. And thanks everyone for joining us today.